Okay, so we have our factory flowchart. So the first thing with our flowchart, we start here. Does a greatest common factor exist? So if there is a greatest common factor, if you can factor out something other than 1, you're going to factor out the greatest common factor, and you can use the cake method. Let's look at some of the examples for this. So if you go to page 10e.1, let's look at this example right here. We have -7 parentheses x minus 4. So first, we are going to distribute this. So we're basically doing the exact opposite of factory for this example. We have -7x plus 28. Okay, we're going to undistribute. We use that cake method. Okay, 4 and 8 both have a common factor of 4. So we could divide these by 4. 4x divided by 4 is 1, so 1x. 8 divided by 4 is 2, so put plus 2. They don't both have an x, so we can't factor out x, so we're done. This is going to go on the outside, so 4 parentheses x plus 2 on the inside. Let's look at this one. 15x minus 5. The greatest common factor of 15 and 5 is 5. So we can factor out a 5. We have 3x minus 1. They don't both share an x, so this is our answer. Our factored form is 5 parentheses 3x minus 1. Okay, let's look at the last one here. -8 and -10 share a common factor of 2 because they're both even. I have -4x minus 5. Notice that both of these are negative. So we're going to go ahead and factor out -1 as well. Okay, they do not both have an x. So we have 2 times -1, -2, parentheses, 4x plus 5. Okay, let's turn the page to the second page of our packets. We're still finding the GCFs, and we're just finding the GCFs of these 3. So let's just look at this example, 8x squared and 64x to the 5th. So if you look at your calculator and go to Add Calculator, go ahead and go to Menu, 2, and 5, greatest common divisor. Type in your 2 numbers, 8, 64, press enter, you should get 8. So the greatest common factor of 8 and 64 is 8, so we can divide out 8. Now, they both have an x, so we could divide out x. How many? Well, we have 2 here and 5 here. So they both have at least 2. We pick the smaller exponent, which is 2, and that's our common factor. When we're dividing by a variable, like this, x squared divided by x squared is going to be 1. Because 2 minus 2 is 0, and anything to the 0 power is 1. And we're going to have 8x to the 5 minus 2, which is 3. So our factored form would be 8x squared, parentheses, 1 plus 8x cubed. It just wanted the greatest common factor, though, so all you'd have to write down is 8x squared. Okay, now for these at the bottom. For these 3 terms, they're all even, so you can divide out a 2. So we have x squared plus 2x minus 6. Well, they don't all 3 have a variable, and there's no other common factors here, so that would be it. 2 parentheses, x squared plus 2x plus 6, close parentheses. Okay, for the next one, 12x cubed minus 2x squared. First, let's find the GCF of 12 and 2. And again, you can always press menu to 5 to find that for your numbers. If you put that in, you should get a greatest common factor of 2, so divide out 2. Okay, after that, ask yourself, do they both have a variable, yes or no? They both have an x, so you can take out x. The smallest exponent is 2. 3 take away 2 is 1. And 2 take away 2 is 0. So nothing else you could take out, so your factored form would be 2x squared parentheses 6x minus 1. Okay, the last one, 39x plus 6. The greatest common factor between those two numbers is 3. So we have 13x plus 2. They don't both share an x, so that's your factored form. 3 parentheses 13x plus 2. Okay, so first of all, when you have a greatest common factor, it exists, you use the cake method. Well, after that, you're going to ask, does it have only 2 terms? If it's a yes, you'll ask, is it the sum or difference of 2 squares? If so, you'll use these equations. A squared plus b squared equals parentheses a plus bi times a minus bi. Or if it's a squared minus b squared, you can use a plus b times a minus b. Okay, let's look at page 9 in our packets. So we have r to the 6th power minus 25. So first you will identify your a squared and your b squared. A squared would be r to the 6th. B squared is equal to 25. Now to find a and b, we have to take the square roots of both of these. The square root of r to the 6th power is going to be the same thing as r to 6 over 2 power. That's r to the 3rd power. 25, the square root of 25 is 5. So b equals 5 and a equals r cubed. So if we plug that into our formula from right here, we're going to have r cubed plus 5 times r cubed minus 5. And you can switch the order of these two binomials. They are commutative. Okay, let's look at the next one, number 9. X squared plus 16. Well, it is 2 terms. It's a sum of 2 squares. So we'll use this formula. So first of all, a squared is going to be x squared. And b squared is equal to 16. Now to find a and b, we take the square roots. The square root of x squared is just x because 2 divided by 2 is 1. The square root of 16 is 4. So a equals x and b equals 4. If we plug that into our formula, we get x plus 4i times x minus 4i. Now let's look back at our chart. What if it's not a sum or difference of 2 squares? Well, then we're going to ask, is it the sum or difference of 2 cubes? If yes, you'll use these formulas. A cubed plus b cubed equals a plus b times a squared minus ab plus b squared. Or a cubed minus b cubed equals a minus b times a squared plus a times b plus b squared. Okay, so let's look at page 10. These are some difference in sums of cubes. So we have m cubed minus 64. So first we need to identify a cubed and b cubed. A cubed is going to be m to the third power. B cubed is 64. Now to find a and b, we need to take the cube roots of both of these. So take the cube root of this one, take the cube root of the other one. Okay, the cube root of m to the third power is the same thing as m to 3 over 3. That's m to the first power, also known as m. So a just equals m. Okay, the cube root of 64 is 4, because 4 times 4 times 4 equals 64. So now we're going to go back and look at our equations. It's a difference. So we're going to have a minus b. So we have m minus 4. And then we have a squared. So it's going to be m squared plus a times b is 4m. And then plus b squared. 4 times 4 is 16. Okay, let's look at this one. Number 7. 27x cubed plus 8. Let's identify a cubed and b cubed. Take the cube roots. Okay, the cube root of 27 is 3. The cube root of x cubed is just x. So a equals 3x. And b is going to equal 2. 2 times 2 times 2 is 8. So we'll go ahead and put that formula in. So a plus b, so 3x plus 2 times a squared, so that's 9x squared, minus a times b, which is 6x, and then plus b squared, which is 4. And if that is a no, if it's not a sum or difference of squares or cubes, if it's neither of those, then ask, is it prime? Is it unfactorable? Okay, so we looked to see if it had only 2 terms, but what if it doesn't? The next question you would ask on your flowchart would be, does it have only 3 terms? And if it's a yes, is it a perfect square trinomial? Basically, can you find a perfect square at the end of this trinomial? If so, see if it fits this equation. Either of these. A squared plus 2ab plus b squared equals a plus b squared. Or a squared minus 2ab plus b squared equals a minus b squared. Let's look at an example for that. So on number 11 of page 5, we have x squared plus 16x plus 64. Well, 64 is a perfect square. So b, in this case, would be 8. And a, your a squared would be x squared, so your a would be x. So you just plug that into the formula. We have a plus right here. So we have x plus 8, x plus 8, which is the same thing as x plus 8 to the second power. Okay, so what if it was not a perfect square trinomial, or you were just not sure? Then ask, is it a general trinomial? If yes, if it's in the ax squared plus bx plus c form, does a equal 1? If so, you're going to do the x factor method. And let's look at some of this stuff. Before we even get to the x factor, you need to be very good with your factors. So, for example, we're going to do a times c was 24. So we're going to list all the factor pairs of 24. So we have 1 and 24, 2 and 12, 3 and 8, 4 and 6, 5 doesn't work, and we already have 6, so that's it. Now we can also do negatives right here. Since the b that we're looking for is positive, though, we don't need to write all those. So let's find our sums of each of these. 24 plus 1 is 25. 12 plus 2, 14, 11, 10. Okay, we're going to match which pair is the b that we have. In this case, it's the 8 and the 3. So after that, you could throw out the rest of them and only use this one for that next step. Now, if you look at the bottom of your paper for page 3, for ax squared plus bx plus c, when a times c is positive, you're going to have the same signs. Basically, they're either both going to be positive or both negative. If the b is positive, both factors are positive. If b is negative, both factors are going to be negative. Now, if a times c is negative, then you're going to have different signs. If the b is positive, the bigger factor is going to be positive. If it's a negative b, the bigger factor is going to be negative. Let's move on to page 4. So we have an x right here. So here's our a times c, and this is our given b. So we want to find two numbers that multiply to negative 72 and add to negative 1. So we could go ahead and draw a table from here. Now from here, we could go ahead and write our factor pairs. And from looking at the previous page, our a times c is negative, so we're going to have different signs. And the b is negative, so the bigger factor is going to be negative. Let's go ahead and put minuses and pluses right here. So you're really going to be subtracting these. And once you find the sums, you compare which one matches the b. In this case, it's the last one. So inside of your diamond, you'll put negative 9 and positive 8. Now, if you could find these right away, you don't have to write the table every time. You could just fill in the two boxes. Okay, now we're on number 9 on page 6. That's for x factoring. So we have x squared minus 8x plus 12. Well, first we will identify a, b, and c. Well, for a, there's nothing in front of x squared, so there's really an invisible 1. A equals 1. A equals 1. Not x squared, it equals 1. B is negative 8. Not just 8, but negative 8. And C is plus 12. Okay, we're going to draw our little x. A times C is 12. And our B is negative 8. So if you need to draw out a table, go ahead and do so. Okay, if you look from that previous page, A times C is positive and B is negative. So both factors are going to be negative in this case. Match which one? It's going to be negative 6 and negative 2. Since A equals 1, we can skip to our answer. X minus 6 times X minus 2. And that's our factored form. Okay, so from here, if A does not equal 1, if it's some other number, then you're going to use a different factoring method. The ones I'm going to show you is X box, X group, and slide and divide. So let's go ahead and look at page 7. That's the slide and divide method. So if you go back to your flowchart and you look at the very, very beginning, you always want to see if you can factor out greatest common factor first. So all of these numbers all end in a 5 or a 0. So that means that you could divide out and factor out a 5. So if we put a 5 out to the side, we have 50 divided by 5 is 10, so 10n to the second power plus 115 divided by 5 is 23, so 23n, and then 60 divided by 5 is 12. So we'll put this 5 out to the side for just a little bit. We're going to slide this 10 over. You're going to multiply it by the 12. So 10 times 12 is 120, so we could just have 5 parentheses n squared plus 23n plus 120. Well, now a equals 1. So yeah, in this case, a equals 1, b equals 23, and c equals 120. So we basically forced our a to equal 1. Well, at the top we put 120, at the bottom we put our b, which is 23. We find two numbers that multiply to 120 and they add to 23. So go ahead and draw your table. You'll write the factor pairs of 120. If you refer back to the other page, a times c is the same side, is positive, and b is also positive, so they're all going to be positive numbers. So try 1 times 120, 2. Okay, so you have all your factor pairs. Let's add them together to find our sums. And then we compare to see which one is our b. Is 15 and 8. So the two numbers we're going to use, it's going to be n plus 15 and n plus 8. Now don't forget our 5. And we also did our sliding, but we didn't do our dividing yet. So what we're going to divide is those numbers that we just found. We're going to divide those by our original a. The next thing you do is reduce these fractions. 15 tenths reduces to 3 over 2. 8 tenths reduces to 4 fifths. So after rewriting it, we have this. But this isn't the proper form. What we want to do now is move those denominators to the front. So those will be our coefficients in front of the ends. So our factored form using the slide divide method would be 5 parentheses 2n plus 3 times 5n plus 4. And that's it. Okay, another method is the X box. So if we look at page 8, we're going to do that method. So we have 5b squared plus 42b minus 80. Well, first we see if we can factor out anything. No, they're not all even. They're not all divisible by 3 or 5 or 7. So it looks like there's no GCF here. So let's go ahead and identify our A, our B, not this B, but the b from that formula from before. And c. So a would be 5, b is 42, and c is negative 80. Okay, a times c would be negative 80 times 5. That's negative 400. Okay, our b would be 42. Okay, from here we can write out the factor pairs of negative 400. Since a times c is negative and b is positive, we have different signs and the bigger sign is positive. So go ahead and fill out your table. Okay, so we have the factor pairs written out. Let's go ahead and find their sums. So I have negative 399 negative 198 Wait, the 42 is positive, so the bigger number will be positive here. Okay, compare which one is the B. It's 50 and negative 8. Okay, so from here, we're going to have our box. In the first box, we put 5b squared, our original first term. In the last box, we're going to put our last term, negative 80. And in the middle two boxes, we put our found numbers, plus 50b and minus 8b. From here, we're going to factor out the GCF out of these two terms. The GCF of 5 and 50 is 5. The GCF of b squared and b is b. Okay, 5 and negative 8 do not have a GCF, and b squared and b would be b. 5 times 10 would be 50. Negative 8 times b would be negative 8b. So this would be our factored form. B plus 10 times 5b minus 8. And that's it. Now, of course, if you write out your table, you can't find any factors that work, and you're pretty sure that you've checked all of them, it could always be prime. Now, what if, after you've looked for greatest common factors, and it doesn't have 2 terms, and it doesn't have 3 terms? Well, then you look to see if you can factor it by grouping. If it's a yes, then you're going to factor by grouping. And yes, X group could be if there's 3 terms, but you could do the group with more than just 3 terms. So let's look at page 11, number 5, and 6. So basically what you do is you separate it into 4 terms. They're already like that for you here. So we have 3v to the third plus v squared minus v, 3v minus 1. Now what you want to do here is put parentheses around the first 2 terms, change this to a plus, put a minus right there, and put parentheses around these. Now we're going to factor out the greatest common factor out of these 2 and these 2. The greatest common factor of 3 and 1 is just 1. The greatest common factor of v cubed and v squared is v squared, because the smaller exponent is 2. what we have left over inside is 3v to the first plus 1. Now we're going to see what's the greatest common factor of 3 and 1. It's still just 1. They're both negative, so we're going to factor out a minus sign. V, there's only v on one of the terms, so you can't take out a v. So you're left with 3v plus 1. Notice that these two parentheses items are exactly the same. That means you can factor it out. That's this greatest common factor here. So we have 3v plus 1, parentheses, v squared minus 1. Now, this right here is a difference of squares. If you go back to right here. Okay, so A would be v, B would be 1. So your completely factored form would be 3v plus 1, v minus 1, and v plus 1. And number 6, let's go ahead and make our parentheses. Put a plus sign. There you go. The GCF of 3 and 6 is 3. The greatest common factor of n cubed and n squared is n squared. What's left over on the inside is n plus 2. Okay? The greatest common factor of 1 and 2 is just 1. They're both negative, so we're going to factor out a negative 1. And they both do not share a variable, so we just leave it as n plus 2. Again, the n plus 2's are exactly the same, so we're going to factor them out. So n plus 2, 3n squared minus 1. Now 3 is not a perfect square, so we could go ahead and just leave it like this. And if you can't factor by grouping, you try different combinations, then ask, is it prime? Now, after you do the does the greatest common factor exist, and you do the cake method and factor that out, you can go ahead and use a shortcut using your TI Inspire. Calculate in the calculator, press the menu 333. Write your given zeros, x equals some number and x equals some other number, and rewrite those zeros as this. Let's do some examples for that now. So let's look at these shortcuts. So we have 3x squared plus 5x plus 27. So let's use the calculator. So first you go calculate, then menu, 3, 3, and 3. Let's type in our equation. 3x squared plus 5x plus 27. When you're finished typing in the equation, you press comma x. You put comma whatever letter you used for your expression, and then press enter. Now notice I have a decimal answer right here. So that's not factorable. This is prime. So we go ahead and write on here as prime. And it's also an imaginary solution as well. This letter I represents that there is no real solution. Let's look at the next one. We have 9m squared plus 5m minus 4. So menu 3, 3, 3. Type in your equation. 9m to the second power plus 5m minus 4. And we'll put comma m this time. So we have our zeros. M equals -1 and 4/9. So now we're going to write our equation using those zeros. So we have m plus 1 times m minus 4/9. When you have your zeros, it's always going to be the opposite sides for your factors. Now, just like the slide to divide from earlier, we don't want to keep this denominator here. We'll slide it to the front. So your factored form would be m plus 1 times 9m minus 4. And that would be your factored form using the calculator.